Hello everyone, this is John Hashmat and welcome to Physics Simply. In this video I will be solving the paper for exam for February-March 2016. So let's get started. Question 1 says a driving instructor gives a student a sudden order to stop the car in the shortest possible time. Figure 1.1 shows the speed time graph of the motion of the car from the moment the order is given. So at time 0 we have a speed on the y-axis 18, and then we have constant speed, then the car decelerates uniformly until 4 seconds, it stops at 4 seconds. Question A says the order to stop is given at time 0. I says state the speed of the car at 0 seconds, that was 18 meters per second from the unit of the graph. Double I says suggest why the car continues to travel at this speed for 0.9 seconds even though the order was given. That is due to reaction time or human reaction time. Part B says calculate first the deceleration of the car between time 0.9 seconds and 4 seconds. We can calculate the acceleration as the gradient of the graph. So we need 2 points from the graph to calculate the gradient, y2, y1, x2, and the x1. So this is the first point and this is the last point. This is point 1 and this is point 2. For point 1, the x-coordinate is 0.9, the y-coordinate is 18, and for 2, the x-coordinate is 4 and the y-coordinate is 0. So going back here, we substitute with these numbers. So 0 minus 18, y2 minus y1 over 4.0 minus 0.9, that is x2 minus x1. This gives an answer of negative 5.806, which we can approximate to 5.8. And since the acceleration is negative 5.8, the deceleration will be positive 5.8, and the unit here is meters per second squared. Double I requires the total distance traveled by the car from time 0. So the distance can be determined from the area under the graph shown here. So this whole area here is a trapezium, and we have this base is 0.9 long, and this base is 4, and the height from here to here, this is 18. So first we say distance is equal to the area under the graph, and then we substitute. Base 1 was 0.9, base 2 was 4 divided by 2, and all that is multiplied by the height 18. That gives an answer of 44.1 meters. Question C says describe and explain a danger to a driver of not wearing a safety belt during a sudden stop. We say that the driver will have momentum or inertia, which will cause him or her forward in case of a collision and hit the windshield or the steering wheel. Question 2 says figure 2.1 shows a hammer being used to drive a nail into a piece of wood. The mass of the hammer head is 0.15 kilograms. The speed of the hammerhead when it hits the nail is 8.0 meters per second. The time for which the hammerhead is in contact with the nail is 0.0015 seconds. The hammerhead stops after hitting the nail. Calculate the change in momentum of the hammerhead. We say that the change in momentum is equal to the mass multiplied by the change in velocity. So the mass is equal to 0.15, the final velocity was 0, and the initial velocity was 8. This gives an answer of negative 1.2 kilograms meters per second or Newton second. Part B says state the impulse given to the nail. This was a change in momentum of the hammerhead, and this is a change in momentum of the nail. And in a collision, the change in momentum of each object is opposite to the other one. So if one has a change in momentum negative 1.2, the other one will take 1.2 as a positive momentum or positive change in momentum, and the unit is the same, kilograms meters per second. Part C says calculate the average force between the hammerhead and the nail. Force is equal to the change in momentum divided by the time. We have the change in momentum 1.2 and the time was given in the question 0.0015. This gives an answer of 800 newtons. Question 3AI says on figure 3.1 draw a graph of extension against load for a spring which obeys Hooke's law, which states that the force is proportionate to the extension. So a direct relation is a straight line going through the origin. So this is what we draw. Double I says state the word used to describe the energy stored in a spring that has been stretched or compressed. That would be elastic energy or strain energy. Part B says figure 3.2 shows a model train traveling at a speed v approaching a buffer. The train of mass 2.5 kilograms is stopped by compressing a spring in the buffer. After the train has stopped, the energy stored in the spring is 0.48 joules. Calculate the initial speed v of the train. So applying the law of conservation of energy, the final strain energy stored in the spring is equal to the initial kinetic energy of the train. So 0.48 is equal to half the mass of the train, 2.5, times the speed squared. So we divide by half 2.5 on the other side, and then we square root to remove the square of the speed. The speed will be 0.61968. We can approximate that to 0.62 meters per second. Question 4a says the source of solar energy is the sun. Tick the box next to those resources for which the sun is also the source of energy. So coal, that's fossil fuels, yes. Geothermal, no. Hydroelectric, yes, it depends on the rain. Nuclear, no. Wind, yes, it depends on the difference in temperature on the surface of the earth, so also depends on the sun. Part B says figure 4.1 shows a solar water heating panel on the roof of a house. Cold water flows into the copper tubes, which are heated by solar radiation. Hot water flows out of the tubes and is stored in a tank. Explain why the tubes are made of copper and are painted black. That would be because copper is a good conductor of heat and black surfaces are good absorbers of infrared radiation. Double I says in 5.0 seconds, 0.019 kilogram of water flows through the tube. The temperature of the water increases from 20 degrees to 72 degrees Celsius. The specific heat capacity of water is 4200 joules per kilogram degrees Celsius. Calculate the thermal energy gained by the water in 5 seconds. We use energy is equal to mc delta theta. And the mass here is 0.019, the specific heat capacity is 4200, and the change in temperature is the difference between 72 and 20 degrees. This gives an answer of 4149.6, which we can approximate to 4100 joules. Triple I says the efficiency of the solar panel is 70%. Calculate the power of the solar radiation incident on the panel. That would be the input power. We have the output energy, then we need to calculate the output power. The output power is equal to the energy, which was 4149.6. We divide that by the time, and that was 70% of the energy. So what energy or what power is corresponding to 100%? Because the incident energy, that is the input, that's 100%, and we only absorbed 70% of that energy to heat the water. So we need the 100%. If we do cross multiplication, this bracket by 100 and then we divide by 70, that gives us an answer of 1185.6, which we can approximate to 1200 watts. Question 5a says a student carries out an experiment to find the relationship between the pressure P and the volume V of a fixed mass of gas. The table contains 4 of her sets of measurements. We have the pressure in kilopascal and the volume in centimeter cubed. Use data in the table to suggest the relationship between the pressure and the volume in this experiment. Explain how you reach your conclusion. We should already know that the pressure and volume are inversely proportional, and if we have any two quantities inversely proportional, that means that if you multiply these quantities, you should always get the same result, or it is constant. So if you multiply pressure by volume, you should get always the same value. So if you multiply 250 by 30, 500 by 15.2, 750 by 9.8, 1000 by 7.6, these all give an approximate value of 7500. They are not all the same, but they are approximate to 7500. So we say that all values of P times V are approximately equal, and you can say the number to 7500. So pressure is inversely proportional to volume. So that's how we prove that any two quantities are inversely proportional. We multiply them together. All values should give the same number. And if you want to prove if two quantities are directly proportional, you divide them. So if pressure was directly proportional to volume, so pressure over volume or volume over pressure should always give the same number. Double I says state the property of the gas apart from the mass that remains constant during the experiment. For the pressure to be inversely proportional to volume, we need constant amount of gas, which is the mass, and we need constant temperature as well. Part B says a lake is 5 meters deep. The density of the water is 1000 kilograms per meter cubed. First, calculate the pressure at the bottom of the lake due to this depth of the water. So we can use pressure is equal to rho GH. The density is 1000, G is 9.8, and the depth here is 5 meters. This gives an answer of 49,000 Pascal, or we can write that in standard form, 4.9 times 10 to the power of 4 Pascal. Double I says a bubble of gas escapes from the mud at the bottom of the lake and rises to the surface. Place one tick in each row of the table to indicate what happens to the volume and the mass and the density of the gas in the bubble. So the mass does not change. So for the mass here, we tick stays the same because the amount of molecules does not change. But going upwards, the pressure decreases, and as the pressure decreases, the volume increases because they are inversely proportional, so volume increases. And for density, it is equal to mass divided by the volume. So density and volume are inversely proportional. So if volume increases, the density decreases. Question 6a says figure 6.1 represents the waveform of a sound wave. The wave is traveling at constant speed. Part I says on figure 6.1 label with the letter X the marked distance corresponding to the amplitude of the wave. That would be from the central line or the undisturbed position to a crest or a trough. So this is the amplitude X. Part 2 says label with the letter Y the marked distance corresponding to the wavelength of the waves. That would be the distance between two similar points or two corresponding points. That would be this point and this point at the same level and forming the same pattern. So this is the distance of the wavelength, Y. Double I says state what happens to the amplitude and the wavelength of a wave if the loudness of the sound is increased at constant pitch. So loudness is dependent on the amplitude. So if the loudness increases, the amplitude increases. And since the pitch is constant, then the wavelength or the frequency does not change or constant. Because of this equation, speed is equal to wavelength multiplied by the frequency. So if the speed is constant and the frequency is constant, the wavelength must also be constant. 2 says the pitch of the sound is increased at constant loudness. Constant loudness means the amplitude is constant or did not change. And the wavelength is inversely proportional to the frequency for the same speed. If frequency increases, the wavelength decreases and vice versa. So now the pitch is increased, so the frequency increase. So the wavelength here will decrease, or we say decreases. Question B says a ship uses pulses of sound to measure the depth of the sea beneath the ship. A sound pulse is transmitted into the sea and the echo from the seabed is received after 54 milliseconds. The speed of sound in seawater is 1500 meters per second. Calculate the depth of the sea beneath the ship. So the distance traveled is twice the distance we want to get. So this is d and this is d. So the total distance is 2d. We can calculate the speed as 2d divided by the time. And we need to calculate d. So d is equal to speed multiplied by time over 2. And we have the speed 1500. The time is 54 over 1000 to get the milliseconds into seconds. So 0.054. And then we divide that by 2. That gives an answer of 40.5 meters or approximately 41 meters. Question 7a says explain what is meant by total internal reflection. We say that when a ray of light is incident towards a less dense medium, light reflects without any refraction. So the light does not go through the medium, it bounces back. Double I says state what's meant by the critical angle. We say that it is the angle of incidence in a denser medium, giving an angle of refraction 90 degrees in the less dense medium. Part B says figure 7.1 shows a ray of light traveling in air incident on a glass prism. Part I says the speed of light in air is 3.0 times 10 to the power of 8 meters per second. Its speed in glass is 2.0 times 10 to the power of 8 meters per second. Calculate the refractive index of glass. The refractive index is equal to the speed in air divided by the speed in the other medium. The speed in air is 3.0 times 10 to the power of 8. The speed in the other medium, which is glass here, is 2.0 times 10 to the power of 8. So it is the same as 3 divided by 2. That gives an answer of 1.5. And there is no unit for the refractive index. Double I says shows that the critical angle of the glass air boundary is 42 degrees. We can use n is equal to 1 over sine the critical angle. So the calculated refractive index 1.5 is equal to 1 over sine the required angle here. We can exchange the position of these two. So sine the critical angle is 1 over 1.5, and then we use the calculator to calculate shift sine answer. So we calculate 1 over 1.5 and then we hit equal, and then we calculate shift sign answer. We press shift sign answer to get the angle, and the angle here is 41.8, which is approximately 42 degrees as required in the question. Triple I says on figure 7.1, draw carefully without calculation the continuation of the ray through the prism and into the air. So the ray entered here at 90 degrees, so it will keep moving forward without bending. It refracted, it changed speed, but it did not change direction because it was incident at 90 degrees to the boundary. And now if we draw a normal to this line, the angle between the normal and the ray is actually more than the critical angle, more than 42 degrees, because if this is 30 degrees for the right angle triangle here, this is 60, which is greater than 42, so it will rebound or reflect, total internal reflection, with another 60 degrees on the other side. But the question said no calculation, so we will draw an approximate ray, so it will reflect like this, going in this direction, and from here we have a normal to the boundary, and going from a denser medium to a less dense medium, the speed increases, so the ray will not move in the same direction, it will bend away from the normal, and the final direction is like this. So this is without any calculation, without calculating the angle of incidence here and without calculating the angle of refraction here. But this is total internal reflection, so we should draw this angle approximately equal to this angle. That's why the ray did not fall here at 90 degrees. It fell with an angle, so it bent away from the normal. Question 8a says figure 8.1 shows 3 lamps and a fuse connected to a power supply. The EMF of the supply is 220 volts. Each lamp is labeled 220 volts and 40 watts. So this is the normal operating voltage and power. The rating of the fuse is 2 amperes. This is the maximum current it can take before melting. Calculate first the current in each lamp. We have the voltage and power. So power is equal to voltage multiplied by current. So current is equal to power divided by voltage. We have 40 watts divided by 220 volts. That gives an answer of 0.18 recurring, which is approximately 0.18 amperes. Double I says calculate the current in the fuse. We have 3 lamps in parallel, each carrying 0.18 amperes. So the total current in the circuit and the fuse will be 3 times 0.18 or 0.18 plus 0.18 plus 0.18. That gives an approximate value of 0.55. If we use the actual number, it will be 0.54 recurring. So it will be approximately 0.55 amperes. Triple I requires a total number of lamps all in parallel that could be connected without blowing the fuse. So if the total current is equal to the number of the branches multiplied by the current in each branch, we can write that as 2, the maximum current, is equal to unknown number multiplied by 0.18. So the number of lamps is equal to 2 divided by 0.18 recurring. That gives an answer of 11.1 recurring. So it's either 12 or 11. If we connect more lamps, the current will increase. So we need to connect less lamps. So 11.1 will be finally 11 lamps. This is not about approximation, this is not about rounding, this is about the fact that if you connect more branches in parallel, the current will increase. If you connect less branches, the current will decrease. Question B says, after a very long period of use, the wire filament of one of the lamps becomes thinner. Underline the effect of this change on the resistance of the filament. As cross-sectional area decreases, becoming thinner, the resistance actually increases, so we underline this. Double I says state and explain the effect of this change on the power of the lamp. So the lamps were connected in parallel, so they have the same voltage. So we can use the equation of power is equal to V squared divided by R. So for the same voltage, the power and resistance are inversely proportional. So we say as resistance increases, the power decreases. Question 9a I says state what is meant by the direction of an electric field. It is the direction of the force on a positive charge or a free positive charge placed in the field. Double I says figure 9.1 shows a pair of positively charged horizontal metal plates with the top plate positive. The electric field between the plates in figure 9.1 is uniform. Draw lines on figure 9.1 to represent this uniform field and arrows to these lines to show the direction of the field. If we have a uniform field, the lines will be parallel and equally spaced. You do not need to draw a lot of lines. Just make sure that they look equally spaced like this and parallel. You can draw another line here And last, the direction is from the positive charge to the negative charge, so here it is pointing downwards. So parallel equally spaced lines from positive to negative. Question B says figure 9.2 shows a very small negatively charged oil drop in the air between a pair of oppositely charged horizontal metal plates. The oil drop does not move up or down. Suggest in terms of forces why the oil drop does not move up or down. It should fall due to gravity, but there must be an upward force opposite to the gravity force to keep it in place, or for the forces to be balanced, or the resultant force to be zero. We say that the electric force due to the plates must be upwards, and these forces must balance. So we say that the upper plate must be positive, so the upwards electric force balances the downwards gravitational force or the weight of the oil droplet. Double I says without losing any of its charge, that means that the electric force is the same. The oil drop begins to evaporate. That means that the mass decreases part by part. State and explain what happens to the oil droplet. We say that the mass and the weight decrease, but the electric force did not decrease, so now the resultant force is upwards and the drop accelerates upwards. So now there is a resultant force in a certain direction, there will be an acceleration in the same direction. Question 10a says an iodine isotope I-131 and 53 decays by beta emission to an isotope of xenon. First, state the number of each type of particle in a neutral atom of iodine. So the number of protons is the proton number here, 53, and the neutral atom has equal number of electrons, so electrons are also 53, and the neutrons is the difference between the nucleon number and the proton number. That gives an answer of 75 neutrons. Double I says state the symbol in nuclide notation for the xenon nucleus, which is Xe. And now by beta emission, the number of protons increases by 1, so it will be 54, not 53. And the nucleon number does not change, so it remains at 131. Part B says the background count rate of radioactivity in a laboratory is 30 counts per minute. A radioactive sample has a half-life of 50 minutes. The sample is placed at a fixed distance from a detector. The detector measures an initial count rate of the sample, including background, 310 counts per minute. So we need to subtract background here, which was 30. So we need to subtract 30 to get the initial reading. On figure 10.1, plot suitable points and draw a graph of the count rate from the sample corrected for background. That means subtracting background as it changes with time. So we have the half-life 50 minutes. So every 50 minutes the activity decreases by half, and the initial activity was the detected reading minus 30, so 310 minus 30, that gives 280. On this graph, each 2 squares makes 10, so this is 290, this is 280, so this is the first point. And every 50 minutes the reading decreases by half. So at 50 minutes we have half 280, which is 140. So this is 110, 120, 130, and 140. And for this at 50, the point will be here. Now another 50 minutes passed, we get 100 minutes, and the reading decreases by half 140. Half 140 is 70. So this is 90, this is 80, and this is 70. And this goes at with the 100-minute mark. So we have another point. We still have space for the third point, which is 150 minutes. After another 50 minutes, another half-life, the reading decreases by another half. So 70 divided by 2, that gives 35. This is 10, 20, 30, 40. So 35 is here at 150 minutes. So these are the points. We need to connect a line which looks like a curve. This is the best curve I could get. It doesn't have to go through all the points, just to be as smooth as possible. Question 11 is about logic gates, which was removed from the syllabus, so you can skip this question. It says in part AI, figure 11.1 shows a symbol for a logic gate and its truth table. This is an AND gate. State the name of this logic gate, so this is the answer. Double I says complete the truth table for the logic gate shown in figure 11.2. This is a NOR gate. A NOR gate is the opposite for an OR gate. An OR gate only gives 0 when 2 inputs are 0. The NOR will be the reverse, so it only gives 1 when 2 inputs are 0 and the other inputs will give an output of 0. Part B says figure 11.3 shows the system of logic gates used to ensure the security of the strong room of a bank. The strong room door will only open when the output F is logic 1. Complete the table to show the logic states at A, B, C, D, and E when the strong room door can be opened. So if this is 1 and we have an AND gate here, the two inputs of the AND gate must be 1, so D and E must be high or 1, and 1 coming from an AND gate at the top here, the inputs A and B must also be 1, so A is 1 and B is 1, and 1 coming from a NOT gate, that means that the input C is 0, because a NOT gate reverses the input. So this was the end of the exam. I hope you enjoyed this video and found it useful. If you did, give the video a thumbs up and subscribe to the channel, and I will see you in another video.